Look at this question. Sometimes they give like this. Okay, this is a silicon, this is germanium, 1 volt battery. Okay, and they ask you that they will give you the potential barrier for silicon is 0.6 volts, and for germanium the potential barrier is 0.3 volts. Okay, and you have to tell what is the potential drop from this point to this point. Point A, B. So the options are all volts. Okay, the circuit is given like this, in which one silicon PN type diode is connected, and another is connected with germanium type, and the potential barriers of silicon and germanium is given, and you have to tell what is the potential drop from A to B. Now here the silicon is 0.6 volts and germanium it is 0.3 volts. So the passage of current will be only in this path and not in this. Okay, so the potential drop will be 12 minus whatever is the least of these two. Least of these two is germanium. Germanium is 0.3, so that you have to select. Okay, it will not flow, the current will not flow in this path, current will flow only in this path. So 11.7. Option A is the right answer. Yeah. See this question, find maximum voltage across AB in the circuit as shown in the figure. Assume that diode is ideal. He is using a term called diode is ideal. Let us say you have a diode, okay, and this diode is ideal. What will happen? Full current will flow. So this, will there be any resistance? The resistance of this diode will be 0. That is the condition for ideal case. Okay, the diode will not be offering any kind of resistance. So this will purely convert into a wire. Okay, so this and this, they are in parallel. So what is the effective resistance? R dash is equal to 1 by R1 plus 1 by R2. 10 into 15 by 10 plus 15. So this is 10 into 15 by 25. 5 2s, 5 5s, 5 3s, 6 ohms. Now 6 kilo ohms, there is a kilo here, okay. So this is 6 kilo ohms, these two will be now in series. So R2 will be equal to 5 plus 6, 11 kilo ohms. So we have to find out what is the maximum voltage across AB. So we have to find across AB actually, okay. So there is a 5 kilo ohms it is now like this. You have a circuit, this is 5 and this is 6. Let us say connected to a battery of 30 volts. Okay, so how much will go through 6? So we have to just find out the current. What will be the current? Current will be voltage by total resistance. So it will be 30 upon 11. 30 volts divided by 11 kilo ohms. Okay, this is the current. So your A and B is here now. Okay, so what is the current now? Current is 3 divided by 1100. 3 divided by 1100 amps. This is the current. So voltage drop across AB will be equal to IR. I is 3 divided by 1100 multiplied by 6 kilo ohms. So it is 6000. Okay, so 0. So it is 180 by 11, isn't it? It is 180 by 11. Now look at the options. So 11 ones are 11 and it is 70. So 16 point something you are getting. Option 2 is the right answer. Okay, so this is how you have to do it. Next question. See, a circuit is given like this, in which there are two diodes kept as shown in the figure. There is a 1 volt battery and there is a resistor put over there, and it is given in the question that the forward resistance of D1 and D2. D1 and D2 are diodes and their forward resistance is 20 ohms. Okay. Now find the current that is passing through D1. So first of all you need to see in which biasing it has been connected. So this is the nuclear part, NPN. Okay, positive connected with positive, it's a forward bias. Same is the case with this. So when it is positive, when it is forward bias, so current will flow through. Okay, now when current flows through that, so this will this is not an ideal diode. So you need to draw the new circuit in which you have to simply replace this with the resistors. So the circuit will be like this. It is like this now. 20 ohms, 20 ohms. Here there is 100 ohms. Okay. So from here it is very simple. Only thing you have to understand is forward resistance is given as 20 ohms. Okay. So had this been connected in a reverse bias mode, you cannot do like this. So these two are in parallel. So 20 into 20 by 20 plus 20. This will become what? 20 into 20 by 40. It will become 10, isn't it? 20 into, it will become half of these two. So the resulting one will be in series with this. Okay. So the resulting one, remove this 20, it will be like this now. It's 10. So R net will be equal to, these two are in series, so it is 110. So what is the current? Current is V by R. So V is 1. This is 110 amps. Okay. So the answer is this. No. He is asking you what is the current that is going through this. If you observe here, both are 20 ohms, and what will be the current passing through this then? It will be half of, see, this is the I current going over here. Okay. Here it will branch out. Okay. Both are 20 ohms. So this will be I by 2, this will be I by 2. So I by 2 means it will be 1 upon 220. Option D. So let us learn one concept here. Suppose a PN junction is given like this. Okay. A PN junction is given like this. So this is the depletion layer. Okay. This depletion layer width is given as 5 into 10 to the power of minus 7 meters. Okay. So here there is a potential barrier. This is a silicon. So for silicon, the potential barrier, let us say it is given as potential barrier 0.5 volts. So one, you have to find out the electric field in the depletion layer, and two, there is an electron here. This electron clears this depletion layer and it comes over here. So here the speed is given as, V is given as 5 into 10 to the power of 5 meter per second. So second thing what you have to find out is the velocity here. What is the velocity when it crosses the depletion layer? How to do this question? So for the first part, you know that electric field is equal to V divided by the distance. Treat this as two parallel plates, positive, negative, okay, potentials. So what is the electric field in between them means the potential difference divided by the distance of separation. So electric field will be equal to V is 0.5 volts divided by the distance. It is 5 into 10 to the power of minus 7 meters. You can see here it is 0.1 into 10 power 7 or 1 into 10 to the power of 6 volt per meter. You can see how strong is the electric field, isn't it? Now coming to the velocity part. See, if you can apply the energy conservation here. So the electron here is possessing this much of speed. So half mv square. It is crossing over this region. So it will gain some potential energy. What is that potential energy? EQ. So E is the charge, and you know that U is equal to VQ. Okay. So charge here is E, and potential here is the barrier potential plus half m v2 square. Okay. So the total energy possessed by the electron is, some part is used for gaining the potential energy and the rest part converts into the kinetic energy of the electron in the beyond the depletion layer. So here we have to just solve this now. So what is this m? M is the mass of the electron. So we can, because we are trying to find out v2, we are trying to find the velocity here. We have to find v2. We have to find v2. So half m into v1 square minus v2 square is equal to E times v. I am just writing here now. 9.1 into 10 to the power of minus 31 divided by 2 into v1 square. We put v1 square minus v2 square is equal to 1.6 into 10 to the power of minus 19 into potential 1 into 10 to the power of 6. So v1 square minus v2 square is equal to, this is 10 power minus 19, this is 10 power 6. So this becomes 10 power minus 25 into 1.6 into 10 to the power of minus 25. Okay, this 2 will go that side in the numerator and this will come in the denominator. I am just taking approximate values here. 1.6 into 2, 3.2, this is 9.1. So 3.2 by 9.1 means approximately 1 by 3. So 1 by 3 into 10 to the power of 6. What is V1? V1 is 5 into 10 to the power of 5. So the square becomes 25 into 10 to the power of 10 to the power of 10 minus V square. Okay. So V square will be equal to, bring it this side, 25, 1 by 3, almost you can take it as 25 only. Okay. So V is almost equal to 5 10 to the power of 6. You have to take the exact values. I am not calculating the exact values here, but this is the procedure you should understand and adopt if this type of question comes. So this is based on energy conservation. Okay. See this question. For the circuit shown in the figure, find the output voltage, the voltage drop across series resistance, the current through the Zener diode. So in this circuit, there is a Zener diode. Zener diode is shown by this Z symbol. Okay, and Zener diode has to be connected in reverse bias. Okay, you can see the N is connected with the positive. So the specialty of Zener diode is it will allow current even in the reverse biasing case. So here He is asking you what is the output voltage. See, Zener diode also acts as a voltage regulator. This is the power supply, 120 volts is there. Even if bigger voltage is there, the output voltage because of the Zener diode will be 50 volts. Because you remember this curve, right? So this was the curve. So this is the breakdown voltage of the Zener. After that, it will allow a large amount of current with slight fluctuation in the, with slight variation in the voltage. Okay, this is the IV characteristic curve for the Zener diode. Okay. So the voltage drop across a series resistance. Let us say he has put one resistor over there. So the drop across the Zener diode is 50 volts. So this and this, here also it will be 50 volts only. They are in parallel, so it will be 50 volts. So what is the current that is passing through that? So V is equal to IR. V is 50. I, let us say IL. R is 10 into 10 to the power of 3 ohms. So IL is equal to 5 into 10 to the power of minus 3 amps or 5 milliamps. This is IL. Okay. So the answer for the second question is this. Now the current through the Zener diode. We have to find what is the current that is flowing through the Zener diode. Now look here. The supply voltage is 120 volts. 50 is taken by the Zener. So when it is crossing this resistor, what will be the drop? The drop will be 70 volts. This I have discussed in one of the illustrations in the previous videos. Okay. So 50 is taken by the Zener diode. 120 is the supply. So when it crosses the resistor, the drop will be 70. So 70 is the drop. Let us say the current is I. R is 5 into 10 to the power of 3 ohms. So the main current is 14 milliamps. Okay. Now look at this junction. What is happening here? Apply KCL. Okay. So I is equal to IL plus I Z. So I is 14 milliamps, IL is 5 milliamps plus IZ. So IZ will be 9 milliamps. Okay. So 9 milliamps is the answer for the third question.